positive sign, and then you have an absolute value and then a negative sign.
Gotcha. Okay.
It's like I thought I had it last week, and then I went home, and then it went.
And what'll help you is where do absolute value signs belong in the order of operations? Where do they fall into the order of operations? Absolute value signs. Parentheses. I love it. Because, you know, like I was saying, they look like parentheses with better posture, right? So the kind of problem you're talking about is this here.
Yes.
Okay, so this negative out here, can anybody tell me what the real operation is?
No. Absolutely.
Like if I had this,
Let's make it a
it's
positive.
multiplication, right? And it means
Yeah.
sitting next to something else is multiplying. There's an understood one here if you really like that even better. So like -1 times something. So over here, is there anything to do here? That order operation says you better start here. Is there anything to do here?
No.
No. So then I'm allowed to go to the next step, which is multiply. It's the only other thing left in there. So what is negative times -2? Positive 2. Now, order operation says start here. Those are parentheses that are standing up straight. So I got to start there. Anything associated with that I need to do? What does absolute value mean?
The
Distance
distance
away.
from 0.
I love it. So always make this thing come out
Positive.
positive or 0, at least, right? So this, what's the absolute value of -4? 4. That, still there, right? Nothing's happened with this yet, right? It's the negative this. Okay, well what's this? 4, so it's -4. You did this work first, and then the negative is there. So it's a lot like this here. What do you got, Jeff? So what does order operations say? Do I exponent first or do I multiply first?
No, exponent.
Exponent is first, right? That's please excuse. That's the excuse step. So what's -2 squared?
4.
Positive 4, right? -2 times -2 is positive 4. So this is 4. That is still there. I haven't multiplied by a negative yet. So I squared that and got 4, and there's a negative sign in front of it. What's the absolute value of -4? 4. And there's a negative in front of it, right? These two negatives can't kill each other because you have to do the absolute value first before you allow them to multiply by the negative. When you do the absolute value of this, it becomes positive. There is no negative there left to cancel. Yeah?
Why did you only do negative and then you did the little posture thing and like -2 and you only said 2, positive 2?
Definitely, because is there anything to do here? Does this do anything to -2? No. So it's still -2. So then when you multiply, what's negative times -2? Positive 2. Does this do anything to -4?
No.
Hell yeah, right? What's the absolute value of -4? So that is 4. That is still there. Nothing's happened to him. He's just hanging out. He's the opposite of what the hell this is.
So you put on the last one at the bottom. Yeah.
So this says the same thing. It's the opposite of what this is. Because order operation says I must do this first. So he's just got to hang out there until this guy figures himself out, right? -2 squared is 4. And what's 4 times negative? -4.
Then what about the instance where you have like a negative and then the bracket and then just the number 4? I mean,
And a positive, yeah.
Yeah.
Like that? Okay, same thing. What's the absolute value of 4? 4. And there's a negative on it.
So it's
Right.
-4.
-4 still.
So whatever's outside.
So whatever's outside is going to carry down.
Yeah.
Like you're moving it down.
Oh, yeah. Yeah.
Okay.
Until it can get a chance, right? So why over here did it cancel? Because that negative is still there on the next step. Does this do anything to -2? So it's still -2, isn't it?
Right.
So what's next? Multiply. Right? There's nothing, there's no other operation in there that does anything. The parentheses don't do anything. So what's negative times negative? Positive 2. The difference here, I don't have negative times negative. I can't multiply until I've done what this says to do. And what does that say to do? Make that positive. So when I make that positive, is there another negative for this guy to cancel with? No, it's positive 4, so that guy's still there. There's no negative for him to cancel with. Yeah.
Is there anything to do on the bottom? I mean, once it becomes -4 down there on the bottom after the absolute, is there something else to do?
No, this is just sitting there. This is just -4. Is there any
That's just part of an equation or part of it.
No, don't even look at it like that. Just sitting there by itself. That's it.
And that's it. That's as far as
There's nothing else in there to combine with.
There's nothing to do.
No operations I can do anywhere.
Okay.
I'm
got
done
it.
there.
Got it.
Okay, so, I'm sorry, go ahead.
Go ahead.
Oh, so I was, the question was, number 83
83 where?
on page,
Where?
103.
Page 103.
Uh-huh. Where you have to fill in the chart.
Number 83. I love it. Okay, good.
So then it's giving you 31 as a number.
Yeah.
And then you have to come up with the opposite number and so forth.
So the number is 31. And then it says, what's the absolute value?
31.
Page 103. And what's the opposite? So what is the absolute value of 31?
31.
31. Absolute value says, cool, I ain't got nothing to do. You're already positive. So I'll leave you alone. What's the opposite of 31? Negative 31. I love it. And the point you're trying to make there is a point, I haven't even said it because it almost doesn't need saying, but the absolute value of something is not the opposite of that thing always. Absolute value makes it positive, so it's only the opposite when it starts off negative. So for example, they give you a little bit later, negative 13. What's the absolute value of negative 13? 13. And what's the opposite of negative 13? Careful. The opposite of negative 13? 13. So since it was negative, then the absolute value is the opposite of it. It has something to do. It makes it positive, and that's the opposite of what you see. This guy was already positive. The absolute value got anything to do? No. So the absolute value is the same. But the opposite of this would be negative, of course, because it is positive to begin with.
And again, I'm sorry, I keep bringing this, but absolute value, that the minus in there, that just tells you the distance away from 0.
In this case, the distance away from 0. That's right. Because I don't know if you guys remember, and again, when I have just a single number in there, that's all it means, because, and I desperately don't want to overcomplicate this, but really, isn't that the same thing as this? It's like an understood 0 in front. So this is kind of like saying how far apart are 0 and 7, negative 7, right? Okay, so, but when you see this, of course that's going to be 7. We saw this the other day, I don't know if you guys remember. And I said, this says how far apart are 2 and 5. And how far apart are 2 and 5? 3. Just thinking about it, and I would never say, if I say how far to something, you would never say negative. Like if I happen to be standing this way and say how far to a town that's that, you're not going to say negative miles. That's weird, right? Again, what the hell? Do I dig down? What does that mean? So this would be 3. Physically, this should make sense. It should be 3. How far apart are 2 and 5? They're 3 apart. And what do I get when I do the work? What's 2 minus 5?
3.
No. Negative 3. And what's the absolute value of negative 3?
3.
So thank God it agrees with what makes physical sense. 2 and 5 are 3 apart. But when you have just a single number sitting in there, what's it being compared to? 0. That's why it doesn't show up. So if you just have a single number in there, it's always how far from 0 is this number. So how far from 0 is negative 13? 13 away. Yes, sir.
When I did the work, I mean, the answers came out right, but it didn't look like that. Should it look like what's to your right over there? Is that how it should look?
Only you have a problem like this, right?
I mean, but should the structure be the same? I mean, with the line and everything, or should it be on the equal, with an equal sign?
Oh, I see what you mean.
How does it work?
Either way, when it's just a simplification question,
Yeah.
when it's not an equation to solve, if I just say simplify something.
Right.
So if I said, in general, if I said simplify, right, and you could read that.
Right.
Simplify it, and I said 8 over 4. All right, so on your paper, you could write 8 over 4 equals 2, or you could write 8 over 4 and underneath it put 2, and either way, you are simplifying that thing. You with me? But when it's an equation, the equal signs become very important. You have to keep that equal sign in there. You with me?
Yeah.
Here, when I'm just simplifying, you can either designate that is this, or that becomes this on the next day. Either way means the same thing.
And the same thing with absolute.
Same thing with absolutes, because when they say simplify this, you can either go straight across. I tend to kind of like going this way a little bit, because then you can see that becomes 5, right? Is that cool? This piece I have to do first. We know that. Order operation says I have to do in here first. Absolute value -5 is
5.
5, and the negative just comes down. So then what is it? -5. I like it. So it makes a little more sense when you have more stuff to do if you do it like this, vertically. Because then you can you replace this with that, that's still there, it makes a little more sense. When you work this way, a lot of people tend to like to work this way, it's easy to lose something when you work this way. And some of you guys might work this way and be okay with it, but it's harder to follow what's going on if you do that.
Right.
But when it's a little something like this, it doesn't really matter. Like one step and you're done, so there's nothing to follow. Good. Okay. Any other questions from homework?
I'll ask you.
Okay.
I'm not sure what you're asking me to do here. I mean, how you got it wrote, that's all.
Oh, okay. Yeah, see me after for that. Cool. Anything else from homework? Okay. I'll take that as a good sign. I'm an optimistic fool. All right. So what I want to do is I want to do section 2.4 officially. We sort of talked about it a little bit already. Yeah.
So, may I ask what page that's on?
On page 24.
I've walked away from it, so I don't know right now. Hold on.
24.
All right. And I am completely open to suggestions. I kind of like using the workbook because, again, it makes it easier to keep notes. Plus, the less you have to see of my actual writing, probably the better. Right? People say they like how I teach, but you must hate how I write. I couldn't imagine trying to be in my class. But like I don't know if I've said this already, but I had a teacher once that, like, 4th line down, you say, "What did you write in the first line?" He's like, "I don't know. Somebody remember whatever." If I get to that point, that's when I quit. That's it. If I can't read my own writing, time to go away. Okay. So, we've talked about this a little bit already, but let's make it more formal. So now we're multiplying and dividing. And whenever you see the word integers, what that really means, anybody know what that actually means, specifically?
Is that numbers? Is it like simplified to like numbers?
Yeah, but if I say whole numbers, does anybody know what that means? What do you mean by regular numbers? Good, so starting at 0. And the nice thing is when I say whole numbers, they include 0, which looks like a whole, right? So 0, 1, 2, 3. Natural numbers are actually 1, 2, 3. And I used to have this whole thing about, I'm a caveman, I got 1 rock, 2 rock, and then I lose my rock, so then I have to invent 0. So, quick side note. The Babylonians, it wasn't until the very end of their civilization that they actually created the idea of zero. Before that, so for example, if they wanted to tell somebody, bring 4,002 chairs to this event, they had no zero. So they had to put space in there. It had to be in context. They didn't have the idea of zero. And that's so weird to us. But every damn thing you learn in mathematics actually represents thousands of years of thinking and coming up with something, believe it or not. And the idea of zero did not exist for a lot of civilizations. That's crazy. They just didn't need to. They got to the point where they had to come up with something because they were heavy trade with other civilizations, and so they had to have some way of keeping track of things that actually made sense to somebody else reading it. That's a lot of space. Is that 3 blanks or, you know? And this is not false. You can look this up. I mean, this is true. Why did I go off there? Because the whole number start at 0. Integers are, you know, remember a caveman, he lost his rock? So then he has to borrow a rock, so now he's in debt. So now the idea of negative, right? So all integers are whole numbers and they're negatives. So what kind of numbers this does not include yet? Fractions, decimals, you know, true fractions, true decimals. They're not included in this discussion yet. Okay. That's cool. So I kind of like this book's approach to describing why things work the way they do. So maybe this will make some sense to you guys. They try to set up a pattern, which a lot of mathematics tries to do. It tries to look for patterns. So 3 times 5 is 15. 2 5s are 10. 1 5 is 5. And so every time I decrease my number of 5s, the result goes down by 5, right? So therefore, if I keep going, what's the next thing below 0? The next thing below 0. Yeah, so negative 1 times 5 should be 5 below 0. And this is how they explain why a negative times a positive should come out negative. And the way I explained it was kind of like the idea of negative is like an opposite. So whichever way makes more sense, it's nice. This is a nice way of looking at patterns. So this suggests that the product of a negative number and a positive number is a negative number. If there is no other negative in the whole thing, then negative is never going to cancel, right? So if I have something like negative 1 times 2 times 3, will the result be negative or positive?
Negative.
Negative, because nobody kills that guy, right? Mm-hmm. So 2 times 3 is 6 times negative 1? Negative 6. But if I do negative 1 times negative 2 times 3, these two negatives kill each other. Right? So negative 1 times negative 2 is positive 2 times 3 is 6. How are we doing so far? Is that cool? And of course, if I do negative 1 times negative 2 times negative 3. Yeah. So now you got 3. Let me see if I can not flick you guys off. 2 of them will kill each other. So you got 1 left over. Right? So any odd number of negatives will come out negative. Because any pair of negatives will do what? Will cancel each other out when you're multiplying and dividing. This whole thing is about multiplying and dividing. So any pair of negatives will kill each other. So if I have 5 negatives in something, those pair up, ah shit, you got 1 negative left alive. Your answer is going to be negative. Alright, so let me freak you out a little bit more. What's negative 1 to the 4th power? Now be careful. Any 1 to a power is basically still going to be 1, right? Because 1 times 1 is 1. So 1 to the 80 billion power is 1. But the only thing with negative 1 is every pair of negative 1s becomes positive 1, right? So what's negative 1 to the 4th?
1.
Positive 1. You have 4 negatives. No negatives left alive. So what's negative 1 to the 8,477th power? The only thing that matters is the power is odd. So 8,476 of them pair up and kill each other. And there's the one smart guy in the side going, just wait. They're all dead. All right. So then negative 1. Is that cool? Little thing to realize, and some of you guys probably already knew this, but it's kind of useful when that pops up. And they do the same kind of thing here. 2 negative 5s is negative 10. 1 negative 5 is incredibly enough, negative 5. 0 of them is 0. Do you see what's happening here? These are always getting 5 bigger, right? So if I continue it down, negative 1 times negative 5 should get 5 bigger again. That's how they describe why 2 negatives multiply to be a positive. So the shortcut rule, let me see where they put it. Here we go. If the signs are the same, they'll multiply to be positive. Right, so 2 positives, obviously it's a positive. 2 negatives cancel, it's a positive. If the signs are different, they're going to multiply out to be negative. Cool. And the exact same thing happens with division, and that just sort of makes sense. If I have 1 negative in a division problem, like here, the answer will still be negative. There's no other negative to cancel with that negative. But the minute I have 2 negatives in my division problem, those 2 negatives die, and my answer is positive. Same exact way as multiplication. Cool. Maybe. So what's negative 12 divided by negative 4? Because the 2 negatives kill each other. 12 divided by 4 is 3. 11. What's 12 divided by negative 4? There's no other negative to kill it. So 12 divided by 4 is 3, and you got that negative still alive because nobody was there to kill it. I teach a very violent math. That's why I'm using red, I guess, right now. It's not a blood, right? Alright, so there's your ultimate. If they're the same sign, it's positive. If they're different signs, it's negative. Same rule as multiplication. That kicks ass. So a few of these real quick. What about D? When you have a problem like D, you first figure out what the sign is. What's the sign of the answer?
Positive.
Yeah, why is it going to be positive? The 2 negatives cancel. So I've taken that problem out. So now I just worry about the numbers. 8 times 6, 48 times 2,
86.
96, 11. Cool. So I know it's positive to begin with, so then I don't have to worry about the signs at all. What about, these are evil. And they sort of deal with the examples I was giving earlier. So take a second and try H and I out. Don't say anything out loud.
Minus.
Try H and I. Just remind yourself, if there's 2 negatives, they'll kill each other. If there's only 1 negative, it's going to be left alive. So which one of these is positive 25?
Both about
Dissension. All right. So look at H, real quick. Look at H. What do I have 2 of?
negative 5.
I have 2 negative 5s. So if I write it out, negative 5 times negative 5, the 2 negatives cancel. 25.
Oh, yeah, I mean, 25.
All right.
Sorry.
Now look at I. What actually has a square sitting on it? The 5. So this little negative dude, there's just one of them. So this says negative times 5 squared. That square does not get the negative. It can't. That powers are only so powerful. They can only go on the thing they're actually sitting on. So parentheses kind of help them out. It groups stuff together. So that square in H gets to the negative and it gets to the 5. So there's 2 negatives cancels. That square in the I is only on the 5. So this is why sometimes when you plug stuff into your calculator, you put negative 5 squared. I've always, every semester, got a student come up to me and say, it's telling me the answer is negative 25. Well, that's because if you put this in your calculator, it's going to give you negative 25. Because it's doing the right work. You just put the wrong problem in, right? If you want to square negative 5, you better do H. That squares negative 5. I squares 5 and puts a negative on it. So this will be negative 25. And that's really related to the discussion we had earlier with the negative outside the absolute value. Here I've got a square first and the negative sitting outside. Here, the negative is included in the squaring problem, so that's why the negative goes away. Two negatives make a positive. All right, so what about L?
-8.
How many negatives you got in there? So they should do what?
But it's outside.
That's it.
But still.
Yeah, there's it's negative 16.
Oh, okay.
Cool. So if I wanted to make, this is going to definitely be positive 8 because there's two negatives that kill each other, and then you just focus on the 16 and the 2. If I want to make an evil problem, and you know I do, order operations will always save you. Do you divide first or do you square first? So then this is still here. Negative 16 is still there. Divided by, and what's negative 2 squared? 4. Positive 4, because the negative times negative is 2 of them. Cancels. And what's negative 16 divided by 4?
-4.
Good, because there's one negative, no other negative to kill it. So it's still running loose. Negative 4. What about, what's M?
Negative.
Oh, no.
Zero.
Can't find it.
I like it. Undefined.
Yeah.
You cannot divide by 0. I don't care if it's negative or not. 0 is like, undefined. You cannot do that. But what's N?
0.
Good. 0 divided by something is definitely 0. You can't divide by 0, but you certainly can divide 0 by a number. That just comes out to be 0. So be real careful about where that thing is and how your answer should be. Okay, so what I want you guys to work on. And when you're done with this, you can head out. We might have a very short evening for some of us. I want you to do the even problems on this. If you have the book, I only made like 10 copies, so this is page 128 in the textbook. Sorry, in the textbook. Textbook, not the blue book. Page 128. It's the review of section 2:1 through 2:4.
Do we need scratch paper?
You might. Oh yeah, well, you don't want to maybe rip that out, so you probably will. Anybody need a copy of that?
You said even, right?
Even one.
Are we getting in groups?
You can work in groups or alone. Whatever you prefer. All the way to the end.
Is it only 128?
Well, starting on page 128, then going on page 129.
Okay.
Anything else you need that?
So 46.
Yeah.
Yeah. Okay. Anybody else need a copy of that? Okay.
How is the number?
The even ones, all the way through. Even ones. 2, 4, 4, 6. Before I forget, there will be a quiz on the next Tuesday coming up. Chapter 1 through section 2:4. What I just said. Yeah.
Probably a play on words, but our test is actually on the 12th, right?